For 76 years, Pluto was a planet. Small, distant, a little strange, but a planet. It had a place on classroom posters, a permanent spot at the edge of the solar system. Then in the 1990s, astronomers began finding other icy worlds beyond Neptune, in the Kuiper Belt, objects that looked a lot like Pluto. In 2005, Dr. Mike Brown discovered Eris, a frozen world roughly the same size as Pluto, maybe bigger. Suddenly, the quiet question astronomers had avoided became unavoidable. If Pluto is a planet, what is everything else? In 2006, the International Astronomical Union voted. They redefined the word planet. Pluto did not make the cut. The reaction was swift, emotional, global.
I got hate mails, I got obscene phone calls, I got weird online stalkers who yelled at me anytime I appeared anywhere.
Mike Brown became known as the Man Who Killed Pluto. But this was never just about taking a planet away. It was about understanding what's really out there. Because now Brown is searching for something bigger. A true ninth planet hidden deep in the dark beyond Neptune.
I think there's a very good chance that finally we are going to be able to either find Planet 9 with this telescope or collect overwhelming evidence that it exists and point to where it could possibly be.
This week, we're going off the radar to the edge of the solar system with the astronomer who changed it forever. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Well, Dr. Mike Brown, thanks for chatting with me today. I can't wait to hear all about Pluto. My background's in meteorology, but I do love space. So This is very self-indulgent. I'm going to ask you all sorts of fun questions and can't wait to hear all about it. Okay, can we start with a little history of Pluto, like some background knowledge of Pluto, like when it was discovered and some basic stats?
So Pluto's a funny one because it was... People were looking for a planet out beyond Neptune, really from as early as Neptune was discovered, because discovery of Neptune made Urbain Le Verrier extremely famous, and everybody else wanted to be famous. So they predicted there were planets, searched for planets, and the most famous of these searches and predictions was from Percival Lowell, was an astronomer in Boston. And he founded the Lowell Observatory in part to look for this planet that he was predicting. He passed away before it found anything, but they hired Clyde Tombaugh off a farm in Illinois. And he came and started looking for this planet that was predicted. And sure enough, within the first year there, he found Pluto. And it was very easy at the time to think, okay, I've been looking for a predicted planet. The predicted planet was huge, the size of Jupiter or something. He found something out there moving very slowly across the night sky. And so it seemed very obvious that this must be the thing that was predicted, which is why if you look at the New York Times headline, when the discovery was denounced, it was new planet found beyond Neptune, possibly larger than Jupiter, which is wrong by a factor of 250,000. But other than that, it was pretty good.
Okay, so timeline-wise, when was Neptune discovered and when was Pluto discovered?
So Neptune was 1845, and it was legitimately discovered because there were perturbations in the orbit of Uranus that were noticed, and so there was a need for something else to be out there to be tugging Uranus along. Astronomers then started looking at Neptune and said, hey, it looks like it might be a little wonky too. Turns out it's not, but they didn't know that at the time. They had some not great data and predicted that there was this other planet. And so 1930 is when the Lowell Observatory search for this new planet came across Pluto and announced that this must be the planet that Percival Lowell had predicted long ago.
Gotcha. And I heard that their orbits cross each other at some point. Is that true?
So Pluto the planets are all on pretty circular orbits, including out to Neptune. They're all slightly eccentric, but not very much. Pluto, however, is on a very elliptical and inclined orbit, and it's so elliptical that it actually dips inside the orbit of Neptune for a little bit and comes back out further. And it's also tilted by about 20 degrees compared to the planets of the solar system. So it was weird. Even when it was found, this was known early on, it didn't quite fit. It was strange, but there was nothing else really to call it. And people originally thought that it was much, 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 much bigger than it really is.
Plus, it sounds like there was like a desperation to find a planet too.
Everyone wants to find a planet and be famous. Maybe it's my goal too. Who knows?
I was going to say, we're going to dig into that one in a little bit. Okay, stats on Pluto, like size, what's it made of? How far away is it?
I'm going to give you in all these units that the astronomers use because my brain doesn't work in normal human units, but we'll try to work with that. So the size is about 2,400 kilometers across. And that makes it smaller than our own moon by a factor of a couple. I mean, it's really not very big at all. The distance, the average distance, it's on this elongated orbit, so sometimes it's closer, sometimes further. But the average distance is 39 astronomical units. Astronomical unit is the distance from the Earth to the Sun. So that means it's 39 times further from the Sun than the Earth is. For perspective, Neptune is 30 times. So it's a good bit out there. Beyond Neptune. It's made out of a combination of basically rock and ice, like many of the other things in the outer part of the solar system. The outer part of it is ice, water, ice. Sometimes when we astronomers say ice, we talk about other frozen gases besides just ice. But the main ice on the outer part is frozen water ice. It's kind of like on the Earth, we would call it the mantle or the crust or something. But the very top surface is methane and carbon dioxide and nitrogen ices all frozen on the surface there too.
Ah, okay. I never knew why astronomers said frozen water, and now I know.
Just really to
I was like, why would you say that? Now it makes sense.
Yeah.
What about like atmosphere, moons?
So it has, because it has these frozen ices on the surface, the nitrogen, the methane, the carbon dioxide, all of these ices are frozen at certain temperatures, and as you warm up a little bit, they sublime, they evaporate. And because Pluto comes closer and goes further and comes closer and goes further to the sun, it gets warmer and it gets colder. And so when it's cold, everything's frozen on the surface. When it gets closer, things warm up and it actually grows a little bit of an atmosphere. It's still a very little bit of an atmosphere, but it's definitely an atmosphere, predominantly nitrogen, like our atmosphere, but much, much, much less dense than our atmosphere. But still enough that when the New Horizons spacecraft went by it could take these pictures of a little bit of haze in the atmosphere that you could see to these lofting those particles. So pretty cool. It has one major moon, Charon, which is nearly half its size, and the two of those are locked into orbit. You know how our moon always faces the same side of the Earth, so we see one face on the Earth. Charon does the same thing, but Pluto does the same thing too. So it's actually like a dumbbell they're going always facing each other. So if you were standing on Pluto in the right spot, you would always see Charon in the same spot in the sky. If you were standing on the opposite side of Pluto, you wouldn't even know Charon existed because it would be behind Pluto on you. So it's really locked together quite tight like that. Then there's a slew of 4 other tiny moons that are even further out than Charon, which is a quite unusual thing to have for such a small body like Pluto, to have this whole family of moons too. But they're all tiny little icy fragments, probably of the collision that brought Pluto and Charon together.
You said haze. Is there any other like signs of weather on Pluto?
No, I mean, the atmosphere is really so tenuous that it can, because it has nitrogen, because it also has the methane. These things are they are hazes that form in some similar ways that the hazes. I live in Los Angeles. We have haze too, and it's all from things like carbon dioxide and nitrous oxide and all these things that get into the atmosphere interact with sunlight and make tiny particles. Same thing happens on Pluto. It's predominantly that methane that interacts with sunlight and makes these fine particles haze. But that's really all you can see with respect to the atmosphere.
What about I've seen pictures of the heart on
Yeah.
Pluto. What is the heart?
So the heart, what it really, why it's there is still not entirely clear, but what it is a basin. Imagine that you have Pluto here, and then there's this big basin that is, I would say most likely an ancient impact crater where there was this, where it excavated a pretty big chunk. But now the basin has been filled, and it's been filled with basically frozen nitrogen glaciers. You can actually see images of these glaciers coming down into that basin region, and then you can actually see that in this basin, frozen nitrogen is at the temperatures of Pluto. It's not frozen hard. It's more like the consistency kind of toothpaste, maybe. And because it's sitting there on the surface and not totally hard, it actually is convecting a little bit like a mud pot would. And so you can actually see. You can't see it really going because we only flew by really quickly, but you can see evidence of little cells of convection in this big semi-frozen nitrogen lake and pool and whatever it is. And the other weird thing is that frozen nitrogen has a higher density than water, which means that water floats on top of it, which means icebergs made of ice, actual water ice, float on top, which means that chunks of the ice of Pluto sort of come off and then they land on top of this big frozen glacier thing and kind of move around as the mud pot circulates around. So you can see just chunks of. Again, you can't see any of it moving because we haven't been back, but you can see all these things that have happened. It's a really, really strange and fascinating place.
Interesting. And you kind of hinted at this, but do we know much about the formation of Pluto?
Well, Pluto, like the other objects out there in the outer part of the solar system, distinct from planets form in a particular way, but these other bodies form in a pretty straightforward way. There's the solar system is building. There is material in a disk all around, and at the very edge of the disk, there's not enough for it all to coalesce into a big planet, but there's enough gravitational pull and stickiness around that smaller chunks start to come together, and then eventually bigger and bigger chunks are out there, and then it kind of loses steam. So in this region where Pluto lives, which is what we call the Kuiper Belt, there are millions of these things that kind of built up to a certain level and then never got any larger than that. The Pluto and Charon system, as we like to call it, then formed a little bit later when Charon would have formed in the same way, and then the two hit each other. And probably what happened is they hit and Charon kind of smeared off the side, slowed down and went into orbit around it and spewed some debris out and made that those other satellites too. But they're overall a product of one of the giant impacts that happened in the outer part of the solar system.
Cool. All right, let's get into how you achieved this nickname as the Pluto Killer. So, take me back to when you started to question this classification of Pluto as a planet.
I mean, really, the moment to start questioning that classification was the moment the very first object was found in this new region, this Kuiper Belt region beyond Neptune, or I should say the second, because Pluto was the first one. So Pluto was discovered in 1930. Nothing else was discovered beyond Neptune until 1992. 1992, one very small object, 100 kilometers across, was discovered beyond Neptune, but it was discovered in a search that covered just a tiny, tiny region of that space. It was not difficult to look at that discovery and say, oh my God, there must be millions of these things out there. That's what Pluto is. It's part of this population of this new region. That's why it never made sense. That's why it's on this weird orbit. That's why it's small. And so really, starting in 1992 is when people who were really paying attention started thinking, oh, well, it doesn't really make sense to call Pluto a planet. At the same time, there was not much appetite for changing it. It had been a planet for, 62 years. Why not just let it keep all the school kids who love the Disney dog happy? It's actually their parents who really love it the most. And then starting in the early 2000s, this survey that I was carrying out, we started finding increasingly larger objects in this region. We found one that was about half the size of Pluto. We're like, well, and we found a couple that are about 2/3 the size of Pluto. It's like, well, I'm not sure what we're going to do. And then finally, we found this one, Eris, which is 25% more massive than Pluto. And you couldn't sweep it under the rug anymore at this point. Either we were going to have to admit that we really shouldn't have ever called Pluto a planet to begin with, or we were going to have to decide how many of these other things that I'd been discovering get to be part of the planet club too. And strangely enough, I was kind of one of the main proponents of saying all these things I have been discovered, they're great. I love them. They're not planets. It makes no sense to call these a planet. And by the way, Pluto is just one of these things too. And we should just put them all into their own category, which is where they rightly deserve to be.
Okay, so who gets to decide what's a planet and what's not a planet, and what's the difference, and what does Pluto then become?
Yeah, so there is by international treaty, this decision is the decision of the International Astronomical Union, which was formed, I don't know, it was one of these things that was formed post World War II to codify, in this case, everything in space. And so the International Astronomical Union had a vote of how to do this classification, and the vote was overwhelming, and I would say correct, that we are going to call the 8 planets. They are distinct, they are big, they formed in different ways, they are on these stately circular orbits around the sun, and all these other things that are on crazy elongated orbits, tilted one way, tilted the other way, flitting in and out of the planets. We're going to call these, collectively, we call them different things. Between Mars and Jupiter, we call them asteroids. Outside of Neptune, we call them the Kuiper Belt. The big ones we call dwarf planets, but that term has never really caught on, so we don't really use that much anymore. But that's who decided, and that's how the decision kind of went down.
Okay, when did this happen? And did you have to pitch it to them? How do you go about doing that?
2006, there was an International Astronomical Union meeting in Prague where this vote was going to happen. I actually decided the best thing for me to do was to get as far away as possible. That I kind of felt like nobody wanted me to tell them what to do about these things I had discovered, and it was cleaner if I just stayed clear. So I actually took my wife and my daughter. We went up to this little island in the San Juans off of Seattle and tried to escape from everybody and not have anybody know where we were. And I was found. And so as this meeting went on for 2 weeks, there were these proposals and counter proposals, and it got to be sort of a news event. And the news media found me on this island in the San Juans. And so I started talking to people. And in the end, I basically had to say through the media, it's like, look, you guys, they were going to make everything be planets, and the word planet was going to be ridiculous and anything. It's like, this is dumb. It really doesn't make sense to call any of these things I found planets. Let's leave it this. And in the end, this was how the vote happened. And so even though I wasn't there, I think I influenced, I hope, people to make the decision in the correct way. I think it helped having, if the original proposal had held, I would be the greatest planet discoverer in solar system history, and I would have also been a fraud. And so I'm pretty happy that it turned out the way that it did.
Okay, so then you became the guy that got rid of Pluto. What was that backlash like? Was there backlash?
Oh yeah, so for years, there were. I got hate mails. I got obscene phone calls. I got just kind of weird online stalkers who yelled at me anytime I appeared anywhere. And people would often say that like, oh, think about the kids. What are you doing? And it was never about the kids. Kids loved the fact that their parents were wrong and they knew the real story. It's the parents who were thinking about themselves as kids and learning about Pluto who were very upset about this. We're coming up on the 20-year anniversary, and you don't hear too much of the arguing back and forth anymore. It used to be like once a year there would be a headline in some newspaper saying, scientists are reconsidering whether Pluto should be a planet or not. And the answer was always like, it's the same three scientists. Every year they try to put out something to make you try to think that there's actually some debate going on. And there's no debate. And there really hasn't been for 20 years. We're pretty generally satisfied with understanding how Pluto and the rest of the solar system should be classified out there. And it works pretty well.
There has to be like a level of weight that you feel though, being, when you look at like children's books, like even I have a Dr. Seuss book that I think is outdated from, it must have been more than 20 years ago. You changed history and you must see that like frequently. What's the weight of that like?
Mostly I just think I'm amused by it. Like I will, somebody will give me, here, sign this for me. It's all the planets. It'll have Pluto on there. And so I'll cross out Pluto. Can't have on that. I don't know. I've lived with it for 20 years, so it just seems normal to me that's the way things are. It's still it's funny because it's my daughter said to me one time, this must have been 10 years ago now. She was like, Dad, do you know how to get everyone to stop hating you? I'm like, first, I disagree with the premise of your question. Second, please tell me the answer to this question. She's like, all you got to do, you got to find a new planet and call it Pluto, and then everybody will be happy again. I'm like, all right. So she's clearly sort of thinking about this too, and trying to figure out how to fit all this into her world also. So it's fun. I'm happy that I feel like my role was to help us understand as scientists the solar system better, but also, I'm a professor, I'm an educator. I find it important to have the public understand the solar system better. And considering Pluto a planet and classifying it as a planet is just wrong for your understanding. It's like, it means you do not understand the actual solar system around you. And my job is to make you understand it better. So I'm pretty happy with that role.
I read somewhere that New Mexico, like the state of New Mexico, kind of rebelled against this decision.
Yeah, they voted, if I remember this right, they voted that whenever Pluto crosses overhead in New Mexico, it's a planet in New Mexico or something like this. Like, okay, fine. I think that's all kind of funny, though Pluto was discovered in Arizona at the Lowell Observatory by Clyde Tombaugh. Clyde Tombaugh in his later years was a professor at the University of New Mexico, which is the New Mexico connection. I mean, it's cute. It's fun. I think it's perfectly fine to have fun with all this. I also think it's important to understand the reality of how the solar system is.
Yeah, I mean, even now, just talking to you, like my mind is kind of opening up from like this very typical what we think of as a solar system as kids with like this thing with things going around it. And now I'm like picturing something so different because there's so much unknown like beyond Neptune, right? There's just stuff out there that we don't know about. And you're still searching, right?
Right.
So tell me about the search for Planet 9.
So all crazy astronomers at some point in their life have to, decide that they want to go find a new planet. So I guess it's my turn. And it's funny because if you go back and look at the history of people who have claimed there's another planet out there in the solar system, they have been correct precisely once, Neptune, and incorrect dozens and dozens of times, and usually sort of embarrassingly incorrect. So my turn. But I think I'm right this time, even though everybody else has always been wrong. I think I'm right. Here's why. So the reason we think there's another planet still to be found out there, it's a little bit like the discovery of Neptune, which was you saw perturbations to the orbit of Uranus, and those pinpointed a new planet out there. What we see instead of perturbations to any single planet, we see perturbations to many of these objects in the outer part of the solar system in this Kuiper Belt region, and in particular to these ones that are on extremely elongated orbits that go out much, much further than the planets do, and on things like 10,000 year orbits to go around the sun. So, and as they travel these much longer distances, they get more weakly bound to the sun and more able to be influenced by whatever else is out there. And what we found is that these most distant ones appear to be tugged by a really large planet still to be found out there. Now, by really large, I don't mean like slightly larger than Pluto, and let's all argue about if it's a planet or not. I mean, this would be the 5th largest planet of our solar system. It would be something like 8 times the mass of our Earth and several times larger and really, really far away, but still a planet in our own solar system.
Interesting. So it's wild to me that like we had these deep space images from like James Webb, but we don't know if this planet exists in our solar system.
Yeah, here's why. So if you told me exactly where it was, I could point James Webb to it and we would get beautiful pictures. It'd be fantastic. So it's not hard to see. It's hard to identify. And the analogy I like to use is like if I pick up a grain of sand and show it to you, that grain of sand is not hard to see. Now I throw it on the beach and I say, go find it. And you're like, I just put it on. And it's the same thing. If you see planet 9 in the sky, it looks like a star. It's a point of light. You can't tell the difference between it and anything else. The very simple way to know it's planet 9, though, is to take a second picture a day later, and you'll notice it move ever so slightly in the sky. And that's the signature of planet 9. We have telescopes that are looking at the sky night after night after night, trying to find these sorts of things that move and change. But right now, those telescopes are small. They're not big enough to see something like planet 9. This is all about to change like any day now with the Vera Rubin Observatory in Chile is just about to come online. It's a big telescope. It covers the sky night after night after night. Every approximately 3 days, it redoes the whole sky. And this will, if you gave me $1 billion and said, go build a telescope to find planet 9, I would give you that $1 billion. Maybe I wouldn't give it back, but I would say, I don't need it. That telescope in Chile is exactly the telescope to do this. So I think there's a very good chance that finally we are going to be able to either find planet 9 with this telescope or collect overwhelming evidence that it exists and point to where it could possibly be.
Wow, cool. So they just let you use it. Like it's all, everyone works together. Is that how it works?
They let me use it, and they let you use it, and they let everyone else use it. In fact, it is an interesting telescope. It really does just scan the whole sky night after night after night, and then all the data are public. So anybody can go find whatever they want in this data set. And one of the things that means is that, sure, I'm going to be looking for planet 9 in this data set, but I'm pretty sure I'm not going to be the only one. We've done a pretty thorough job of publishing our predictions, where it should be, how to look, how to do it, and other people doing it. And I feel like, I am of an age where I grew up. I mean, I even used photographic plates for some of my astronomical work, and the earliest of the digital cameras and using computers was still pretty new on this kind of stuff. Kids these days have grown up natively in these big databases and using cloud computing, all this stuff. So my guess, if I could predict who's going to find it, it's going to be some graduate student who first heard about Planet 9 when she was in high school or something, went to college, went to graduate school, figured out how to do all this stuff, and just goes and does it in ways that I could never even comprehend, and discovers Planet 9. And that's great. I will be delighted if something like that happens. And I mean, probably be more delighted if I find it. That'd be great. It's just a fun story. I mean, it's new. It's a new era in astronomy, and it's the people understanding how to do this best, which is not me at this point anymore, who I think have the advantage and will do it.
Wow.
But
Cool.
I'm gonna try it.
But if you do it, do you get to name it?
Yes.
Do you have a name in mind?
So no. In fact, I'm sticking my fingers in my ears in case you don't say anything. I and I think most astronomers are very superstitious. And one of my very strongly held superstitions is if you name it before you find it, you're not going to find it.
So
we do
this
not.
This is like an unborn baby.
Exactly. So this is why we call it Planet 9 as just a sort of generic phrase, and we'll name it when we find it. Interestingly, the International Astronomical Union has rules for naming of everything in the sky. Craters on Mercury have to be named after artists and poets. Moons of Uranus are named after characters in Shakespeare. I mean, there's all kinds of like names, rules for everything. The one thing they don't have a rule for is, what about new planets? Because you're not supposed to find new planets. No one thought there was going to be new planets, and no one thought there needed to be a rule for new planets. So I don't actually quite know what the convention we're going to be. I have proposed not a name, but one of the things I have suggested for if we find it or someone else finds it, I think it would be appropriate to name it after the mythology of wherever it was discovered. If it's Chile, then I think that region. If it's found somewhere else, I think that region. If it's found in space, gets a little complicated. I don't know what that means. But I think that would be a nice something for where the telescope was.
Did you get to name Eris?
I did. Eris was the best name. I have second, maybe the best name I've ever come up with. Maybe the second best name I've ever come up with. Eris is, of course, famously the goddess of discord and strife, and the one who started the Trojan War and all kinds of fun stuff. When we were looking for a name for this object, there were not many mythological names that had not already been used. All the names are used for asteroids, things in the Kuiper Belt, all these other things. And of the major gods and goddesses in Greek or Roman mythology, Eris was nearly the only one that had never been used. And I think people were scared of it just because it sounds a little bit weird. Or it was fate. Maybe it was just fate. Maybe I should start believing in astrology. I'm not sure. That name, like we came across that name. And for me, the best part of the story is it was important to me. So Eris has a moon, and I wanted to name the moon. We discovered the moon also. And I wanted to name the moon as a sly tribute to my wife, in the same way that Pluto's moon, Charon, was a sly tribute to the wife of the discoverer of the moon of Pluto. His wife's name is Charlene, and so that CHAR is for her, and that's why. And it's also, I mean, it's Charon. What you could not get a better name for a moon of Pluto, right? So it was just perfect in many ways. Eris, I had to quickly look up if Eris had anything associated with it that would fit. My wife's name is Diane, and in fact, one of the children of Eris is Dysnomia, who is which is now the name of the moon, named after my wife. I didn't tell my wife this ahead of time. She was like, "What are you going to name the moon?" I'm like, "You have to wait and see."
Wow!
It finally came out. I'm like, "It's named Dysnomia. It's named after you." And she's like, "Dysnomia? What is Dysnomia?" I'm like, "It's the demon spirit of lawlessness." Honey. So I'm not sure she quite appreciated it as much as she should have.
Yeah. I was going to say, that gives you street cred for Valentine's Day for like the next 20 years at least.
I hope so.
Dr. Mike Brown, is there anything else you want to share? This has been fascinating.
Stay tuned. Planet 9 could well be discovered this year with Vera Rubin. And if not, I'm pretty sure we'll have the evidence that'll, some people are convinced, some people are less convinced. I'm on the very convinced side, but I think by the end of the first year of Vera Rubin, we'll know. It's either there or it's not. We'll either find it or we'll find the evidence that it's definitely there. So stay tuned. There's a lot out to be found still.
Well, I'm glad I got you on the podcast before you became too famous to do so.
It's been fun.
Thank you so much.
You're very welcome.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. Thanks to Dr. Mike Brown for joining me today to talk all about Pluto, and to my friend and fellow meteorologist, Anthony Yanez, for inspiring today's episode. Thanks to the National Weather Desk and Sinclair Broadcast Group for their ongoing support of the podcast, and as always, to my associate producer, Brian Petras, for his help with today's episode. I'm meteorologist Emily Gracie. Make it a great day.